Hello, in this video we're going to be taking a look at a circuit analysis lab. Now, I have already taken the liberty of building the series circuit and the parallel circuit using the PhET interactive website. If you wish to try and build this yourself, just go to phet.com and you'll see the PhET website. We're going to be measuring current and voltage in different parts of the circuit, and we're going to be making conclusions about current in a series circuit, current in a parallel circuit, voltage in a series circuit, and voltage in a parallel circuit. Remember, when we talk about voltage, that is also the same as potential difference. So you might hear me go back and forth between those two terms. Okay, so let me show you what I've constructed already. In circuit number 1, you can see we've got a 12-volt battery connected to a switch, and the current is going to go this way, through over the light bulb, through over the light bulb, through over the light bulb, and then back to the battery again. What we're going to do is we're going to start by measuring the voltage in different parts of the circuit. Let's begin by measuring the voltage, the total voltage across the battery. We are going to take a voltmeter and we're going to take the black end and we're going to hook it up to the negative side. So when you see the battery symbol like this, the long end is the positive end of the battery, the short end is the negative end of the battery. We're going to hook the red end to the positive and the black end to the negative. Then what we'll do is we'll hook up the voltmeter across each of the light bulbs individually and then across all three of them together. Let's take a look. Now, one of the things you should notice about this circuit here is that when I have 3 resistors in series, the total resistance has gone up, and look how slow the current is moving. Well, that's because of Ohm's law. We have increased resistance means decreased current. Think of it as more speed bumps in the road. I'm going to switch it to the schematic drawing so that the symbols look similar to the circuit analysis lab. Please follow along with me here. I'm going to take the data. You're simply going to record the data on your circuit analysis lab. And then we're going to make conclusions together at the bottom. Again, pause, rewind as necessary. And if you wish to build the circuit yourself and experiment with this yourself, please do so. And you can see the website at the top, phet.colorado.edu. And you would look for circuit construction kit among the interactive labs. Okay, anyway, let's begin. I'm going to drag a voltmeter out, and again, I'm going to place the red end to the positive side of the battery and a black end to the negative side of the battery. And you can see the voltmeter is recording 12 volts. So let's go record that. 12 volts. And actually, since voltage is already recorded as a unit there, I'm just going to be recording the number. So 12 total volts across the battery. Then I'm going to take the red end and I'm going to move it all the way over here. And I'm going to take the black end and I'm going to move it all the way over here across. You see, voltage is always measured across because it represents the difference in potential energy for all those electrons that are moving across a resistance point. And so you can see the voltage across the first light bulb is 2 volts. If I measure across the second light bulb, it's 4 volts. And across the third light bulb, it's 6 volts. Let's record those. So 2 volts across the first one, 4 volts across the second one, and 6 volts across the third one. Now let's measure across all 3 of them grouped together. To do that, I'm going to take the red end and move it all the way over here like this, so that all 3 light bulbs are grouped together. And you can see the total potential difference, the voltage across all 3 light bulbs, matches the battery voltage of 12 volts. Right? Hopefully you are seeing that the total voltage in a series circuit, right, 2 plus 4 plus 6 adds up to a total of 12 volts. Let's go down to the bottom. And right now we are doing number 2, observations about voltage in a series circuit. Voltage in series is summed, meaning it's added together. Okay, now what we're going to do is we're going to take a look at current in a series circuit. And we're going to start by measuring the total current in the battery. Then what we're going to do is we're going to place the ammeter directly after resistor 1 to get I1, directly after light bulb 2 to get I2, and directly after light bulb 3 to get I3. Let's measure the current in different parts of the circuit. Okay, so I'm going to take the voltmeter and put it away. I'm going to drag the ammeter out. I'm going to drag this over, and right after the battery, we can see the total current coming out of the battery is measuring to 1 amp. Now I'm going to take this and I'm going to place it after the first light bulb, and you can see it's still measuring 1 amp. I'm going to place it after the second light bulb, it's still measuring 1 amp. And if I place it after the last light bulb, you can see it's still, again, measuring 1 amp. So the current in a series circuit is exactly the same. Right? It didn't change. Okay, now let's go back and look at the voltage again a little bit more clearly. We said that the voltage is summed across the circuit. Well, here's really what happens. If I take a closer look at this battery, and I'm going to change the color to kind of represent this a little better. How about something nice and bright? Okay. Now, the positive side of the battery is actually the 12 volt side. So there's 12 volts across on the positive side of the battery. There's actually 0 volts on the negative side. That's how you get a potential difference of 12 across the battery, because 12 minus 0 is 12. Now what this means is if there were 2 volts across this, 4 volts across this, and 6 volts across this, it means you're subtracting voltage across a resistor. Now let's think about that. It means on this side right here, this is connected to the positive side of the battery. So there would be 12 volts of potential right here. But if you subtract 2, well, what is 12 subtract 2? That means on this side there's 10 volts, right? Because what's 12 minus 10? It's the negative 2 volts. Same idea. If we subtract 4 volts across the second one, 4 volts from 10 volts leaves you with 6 volts. And then if you subtract the 6 volts across the third bulb, 6 volts minus 6 volts is 0 volts, which is exactly the same as we see over on this side over here. Again, the current in a series circuit is the same. Why is that? Because it is literally the same pathway of charge. Yes, you might be going through different resistors, but it's the same pathway of charge. Therefore, it's going to be the same flow rate of charge or the same current. Let's take a look at experimenting on a parallel circuit. We're going to do the same thing. We're going to measure the voltage across the battery. Then we're going to measure voltage across resistor 1, 2, and 3. And then we're going to measure the currents in different parts of the circuit. Let's begin. Okay, so I'm going to go ahead and build this one. Again, if you want to build it with me, go ahead. If you want to just watch, that's fine too. I always start building circuits with one loop, bring it back around to the battery, and you can see if I shut the switch, I have one loop of current going. I'm going to change the battery voltage to 12. There we go. And I'm going to change the resistance to 2. Then I'm going to add on a second loop. Changing the resistance to 4. Just like that. And then lastly, I'm going to add on a third loop. And I'm going to change the resistance to 6 ohms. There we go. Okay, and I'm going to conventional current, turn on the values. You can see those are the exact same values that we have in this circuit drawing right here. If I turn on the current, you should see something remarkably different. The total current coming from the battery is going really fast. Okay, why is that? Because when we have resistors in parallel, you're dividing the total resistance, not adding it. So if the total resistance went down, that means the total current coming from the battery went way up, and you can see how fast it's going. But you can also see when that total current splits up, it's going to go fastest through the lowest resistor. So this is the rule of thumb to live by. Current follows the path of least resistance. So you can see the 2 ohm resistor has the fastest current. The 6 ohm resistor has the slowest current. Current follows the path of least resistance. The highest resistor has the lowest current. The lowest resistor has the highest current. Now let's make some measurements. Voltmeter, the red goes on the positive side. I'll switch it to the schematic over here. The black goes to the negative side. You can see 12 volts across the battery. Let's go ahead and record that. Then what I'm going to do to get the voltage across for the second light bulb, I'm going to move this around over here just like this. I'll move this around over here just like this, and you can see the first light bulb measures 12 volts. The second light bulb also measures 12 volts. And the third light bulb also measures 12 volts. All 3 of them do. And so one of the conclusions we can begin to make about voltage in a parallel circuit is voltage in parallel is exactly the same. We'll explain why in just a moment. Let's take some measurements with current. I'm going to go ahead and put the voltmeter away, take the ammeter out. Putting the ammeter right here, we can see the total current is 11 amps. Let's record that. Now I'm going to take the ammeter and put it after the first light bulb. You can see the current going across the middle pathway is 6 amps, or the current going across the 2 ohm pathway is 6 amps. The current going into the second pathway right here is 3 amps. And the current going into the last bottom pathway, the slowest current, is 2 amps. Something I hope you notice about this is that the current that divides up in parallel circuits adds up together on the other side. 6 amps plus 3 amps plus 2 amps adds up to the total current of 9 amps. So we can say that current in parallel is summed. Now, let's go ahead and take a look at this diagram and break down why these observations. Let's start with voltage. Now, remember what we said earlier. On the positive side, that's where your voltage is. So 12 volts on the positive side. On the negative side is 0. Well, one thing, I'm going to letter off the corners of the circuit here, just like this. I'm going to letter this off as A, B, C, D, and then E, F, G, and H. So if I were to take a look at this, point A is connected to the region of positive potential. So in other words, 12 volts of potential at point A, 0 volts of potential at point E. What is 12 minus 0? It's 12, just like the battery voltage suggests. Now if we use that same logic, point B is also connected to the positive side of the battery. So point B is also measuring 12 volts. Point F is also measuring 0, therefore 12 minus 0 is 12 volts across that light bulb. Point C is connected to the positive side of the battery, which is 12 volts, therefore there's 12 volts of potential at point C, 0 volts at point G. 12 minus 0 is 12 volts. And lastly, at the bottom, point D is connected to the positive side. Therefore, there are 12 volts of potential at point D and 0 volts, because that's connected to the negative side, at point H. 12 minus 0, again, is 12. And you can see 12 volts of potential, the voltage is the same in parallel parts of the circuit. Now, let's explore the point of current. I'll use a different color. I'm going to use different colors to represent this, okay? So the total current coming out of the battery does this, okay? You can see the black current, it's 11 amps, okay? And the 11 amps does this. Most of the amps goes this way. 6 amps goes this way. Now, what do we have left? 6 amps subtracted from 11 amps is 5 remaining amps. 5 amps. Okay, now we take that 5 amps, and that 5 amps is going to split again across the middle pathway. Remember, there were 3 amps going across that pathway. Okay, and then what is 3 from 5? That would be the remaining 2 amps of current. And what is 2 amps from the bottom plus 3 amps? It adds up to 5 amps. So the current that breaks up on one side of the circuit adds together on the other side of a parallel circuit. And the 5 amps plus that 6 amps adds up to the total 11 amps coming back to the battery again. Current into a junction equals current out of a junction. All right, ladies and gentlemen, this has been the Circuit Analysis Lab. Okay, now what we're going to do is we're going to create a summary table to help us with our analysis and our problem solving. Here we go. Make a grid that is a 2x2 grid. Across the top, we're going to write series and parallel. I call this the series and parallel chart. You're going to need this every time we do circuit type analysis. Across the first row, we're going to write current. across the bottom row, we're going to write voltage. So what did we learn about? Take a look at the bottom summary. Current in a series circuit. Current in a series circuit is the same, right? It's equal. Current in a parallel circuit is summed, right? It's added together. Voltage in a series circuit is summed. And voltage in a parallel circuit is exactly the same. We will be using these principles to guide our circuit analysis throughout the rest of this unit. I hope you found this helpful. Please make sure you pause and rewind as necessary. Thank you.